Hey everybody, it's Mrs. Moran and I'm back to talk to you this week about another fraction skill. This week it's comparing and ordering fractions. We're going to use two main strategies for this. This is a very important fourth grade skill and it's also one that really helps us to see who has good fraction number sense. The more we work with these fractions, the more students have seen them in models and they're starting to really understand what these fractions are and their relative size. And we're going to see that some students are able to use benchmarks. And then other students might need a common denominator if they're unable to tell the relative size of some fractions. So benchmarks we're going to be working with today are fractions of 0, half, and 1 whole. We're going to be asking ourselves, is that fraction close to 0, half, or 1? And then if it is close to half, is it less than or greater than half? And we're also going to be learning how to use a common denominator to make the same size pieces for fractions that are a little harder to determine their comparison based on their benchmarks. All right, so we work with a mental number line here of fractions. So we're going to look at fractions that span from 0 to half to 1 whole. And we're going to think about our 0 fractions as being an empty fraction. So if we were thinking about it as a pizza or a pie, this would be like no slices at all. It would feel, could be divided and separated, but not filled in at all. The opposite of that would be a whole fraction. And these are going to be things that are, no matter how many pieces I have, completely filled in. And then we're going to have our most important benchmark, the half fraction, fractions that are equal to 1/2. So starting over here, empty fractions, if I have denominators of 3 would be, no matter if I break it into 3 parts, it's going to have 0 pieces shaded in. 0 out of 4, 0 out of 5, 0 eighths, and 0 twelfths. Those are all our empty fractions, completely unshaded. Over here at this end, we have our full fractions. These are our 4/4, our 6/6, our 8/8, our 10/10, and our 12/12. And then these, again, are our most important fractions. These are fractions that we want students to recognize when they look at right away and know that they're equivalent to 1/2. So if I'm working with fourths, we're always focused on that denominator. So half of that denominator 4 is 2. Half of the denominator 6 is 3. Half the denominator 8 is 4. And half the denominator 10 is 5. I kind of call these my no excuse fractions. I expect students, when they look at a denominator, to know right away what the half is. And if they see these fractions, to recognize them as 1/2. Okay, so that leaves us with some ranges, sort of a spectrum between the 0 and half, and things that are more than half, between the half and the whole. So if we're to look at fractions and think about not fractions that are empty fractions, but fractions that are close to being empty, are small fractions. So these denominators are going to be things like a large denominator, which would have a small numerator, so 1/12, or maybe even 2/12. Those would be very small, almost empty fractions. 1/10, 1/8, 1/9. Now students sometimes get hung up thinking that if it has a 1 in the numerator, that automatically makes it a small fraction. That's not necessary, because we do have the fraction of 1/2, which has a 1 in the numerator, but it's not a small fraction because of its size. 1/3 is not a fraction that's almost an empty fraction, because even though it's only one piece, it's one large piece. And even 1/4 is the exact halfway point here, so we don't really think of that. So small numerator compared to the denominator. The opposite of that over here, at fractions that would be almost a whole fraction, would be things where the numerator is large compared to the denominator. So you might have things like 8/9, 8/10, or even 9/10, 11/12, 5/6, 7/8. Okay, and again, just because it's one number less doesn't necessarily mean that it's a whole fraction. You could have something like 2/3, which is one piece away from the whole, but is really closer to 1/2. We could have something that is 4 numbers away from its whole, something like 96/100. So even though it's a lot of numbers away, they're very small pieces away. So this would still be considered very close to a whole fraction. So really what we're doing here is we're estimating. We're trying to look at the fraction and say, about how big is it? And using our number sense of what our models look like and what the numerator is compared to the denominator. So then we get into what is left. If it's not an empty fraction or almost an empty fraction, and it's not a full fraction or an almost full fraction, then it's got to be somewhere between the halves, so a little less than half, half, or a little bit more than half. So the way we're going to determine that is based on the denominator, the most important part of the fraction, which we talk about all the time. So if I have something like sixth, if 3/6 is the half, then that would make one piece less than 3, 2. And if I wanted something close to half but slightly more than half of 6, if 3 is the half, then 4 would be slightly more than that. Okay, if I have eighths, 4 would be the half, 3/8 would be slightly less, 5/8 slightly more, okay, and 6/8 and so on. Once I get into 7/8, then I'm over here, okay. 3/8 is here. Once I get into 2/8 and 1/8, then I'm down in this area here, okay. So 5/10, we could even go with, pieces are getting smaller now, so even 6/10 and 7/10 would be slightly more than half. We have things like 4/10 and 3/10 being slightly less than half. Fifths. Fifths are a little tricky because as an odd number, 5 doesn't have a halfway point. So we have to imagine the halfway point not as being a whole number, but it does have a halfway point. So if the half of 5 is 2.5, so 2/5 is going to be less than half, 3/5 is going to be more than half. Same thing with the thirds. The half of 3 is 1.5, so 1/3 is going to be less, and 2/3 is going to be slightly more than half. So everything that we're going to do when we compare fractions is going to be first to say, can I make this a simple problem just by estimating, just by doing benchmarks? And if we can, then we make ourselves a very easy problem. If we can't, then we have another step we can go to make it more specific. So these are 3 types of problems we might see in comparison. 1 is, does it have a common denominator? 2, does it have a common numerator? And 3, can I use a benchmark to compare them? So when the common denominator, both of these being tenths, basically means that they have the same size piece. So if I have the same size piece, then the larger fraction is going to be the one that has more of them shaded. So if they're the same size piece in tenths, 6/10 is going to be greater than 3/10. So 3/10 is less than 6/10. Okay, here's another example with eighths. Same size piece, so more counted or more shaded is going to be larger. 4/8 is bigger than 2/8. That's very simple. That's probably a 3rd grade level comparison fraction question. Okay, this is where we really start to see our number sense come in, is do students understand this inverse relationship here? So with a common numerator, now I have 2 in both of these top numbers. Some students would think 2 is the same as 2 and those are equal. Students with a good fraction sense would recognize that a different size denominator means a different size piece. Thirds are larger pieces than 6. If I'm cutting a pizza into 6 slices, they get smaller the more pieces I make. So in this case, when I have the same number of pieces, the larger piece is going to be the larger fraction. So the smaller the denominator, the larger the piece. So 2/3 is going to be greater than 2/6. I call it an inverse relationship here because most students who don't know about fractions would first look at this and think the 3 is going to be the smaller. Smaller denominator, bigger the piece. Okay, again, here's another example. If I have 5 things shaded in of eighths and 5 things shaded in of ninths, eighths pieces are larger than ninth pieces. Inverse relationship there. All right, now when I get to ones like this, I don't have a common numerator and I don't have a common denominator, which means we're measuring different number of different size pieces. And unless students have a lot of experience with fractions or they know how to convert them in their mind into decimals or percents, it makes it much harder to do. So what we're going to do is we're going to use our benchmarks. We're going to ask ourselves those 2 questions I mentioned on the previous page. Is the fraction close to 0, half, or whole? And if it is close to half, is it less or is it more than half? Okay, so looking at my benchmark, 6/8, is that close to an empty, a half, or a full fraction? Well, it is somewhat close to a full fraction, and I know it's more than a half fraction. The half of 8 is 4, so that's going to make this greater or more than half. It's actually the exact midpoint between a half and a full fraction. And then 2/10, this is going to be definitely, if tenths is my denominator, 5/10 is going to be the half. This is definitely less than half. In fact, it's closer to 1, or I'm sorry, closer to 0. So this is closer to a 0 or closer to an empty fraction, and is also less than half, and this one is greater than half. So anything greater than half is going to be greater than something that's less than half. So 6/8 would be greater than 2/10. All right, taking a look at these, can I ask myself, are these fractions close to 0, half, or whole? 5/6 is a mostly full fraction, so we'd say that that's close to 1. It's only one piece away from its whole. 3/8, I should recognize 4/8 is the half, so 3/8 is going to be a little bit less than half. This is my mental thought process here. A lot of students are just quick to put down a symbol in there, and I want to see on paper whether they know their benchmark. So closer to 1 whole is greater than things that are less than half. All right, and lastly, we want to recognize this right away. This is one of those no excuse fractions. 4/8 is 1/2. 7/12, the half of 12 would be 6, so 7/12 would be slightly greater. So this is more than half. Okay, so something that's more than half is going to be greater than something that is half. Okay, so those are our strategies for common denominators, common numerators, and using benchmarks. All right, now in some situations, the benchmarks aren't really going to work out for you, and this would be a situation. Okay, so I'm looking at this, I'm asking myself those benchmark questions. Close to 0, close to half, or close to whole. Okay, 3/8 would be a little bit less than half because 4/8 is half. 2/5, I'm not scared of odd numbers. Half of 5 would be 2.5, so this is a little bit less than half also. So now we have two fractions that fall in the same part of our imaginary number line here. They're both less than half. So to be a little bit more precise and a little bit more exact, instead of trying to look and estimate, we're going to get a common denominator, which means we're going to change these into two new fractions of the same size piece so that we can use this strategy here of finding of just using the numerator when we have a common denominator. So now we're going back to equivalent fractions and thinking about these pieces. Can I make 8ths and 5ths into the same size pieces? They can both become 40ths. Okay, how do they do that? Well, 8ths turn into 40ths by a factor of 5. So I'm going to do the same thing for my numerator. 5 times 3 is 15. Okay, so this becomes 3/8 is equal or equivalent to 15 40ths. 5 can become 40ths by a factor of 8. So 2 times 8 is 16. So now you can see this is why we don't want to just use benchmarks, because we have two fractions which are really, really close together. These are both 40ths, which means they're very small pieces, and this is only one tiny piece more than that. And most students don't have this understanding, where if I were to think about this, I would think about these in decimals, and I know these decimal conversions, and I can do that very quickly. If you can't do that, common denominators is the way to go. Okay, so 16 40ths is greater than 15 40ths, so 2/5 is greater than 3/8. All right, here's another example. What are my benchmarks? 3/4 is more than half and close to a whole. 4/5 is also more than half and also close to a whole. So I'm not going to leave that to estimation. I'm going to look for a common denominator. So is there something that both 4ths and 5ths can multiply to become for the same size pieces? 20ths. 4 becomes 20 by a factor of multiplying by 5. So 3 times 5 is 15. And 5 becomes 20 by a factor of 4. 4 times 4 is 16. So again, two very close fractions. 16 20ths bigger than 15 20ths, so 4/5 is bigger than 3/4. Now, one other way that you can do these is, we talked about this a little bit in class today, that these are each close to full fractions. They're only one piece away from their whole. Because these are larger pieces, the 4ths are larger, that would be less, or it'd be more taken out of the whole, and it would be less as far as close to the full fraction. 5ths are going to be smaller pieces, so it'd be less taken away, which is going to make it a larger fraction. So students will start to recognize that when they're only one number away, the smaller the denominator, the further away from the whole they are. So common denominators, generally the easiest way to go. All right, one last thing is, now can we put them in order from least to greatest? So you still want to try benchmarks, because sometimes that's a really quick shortcut. If you can't do benchmarks, you're going to have to find a common denominator, and sometimes finding a common denominator of 3 numbers can be a little bit challenging. So let's take a look at this. 3/6 right away I know is half. 1/8, that's going to be a close to 0 fraction, and 6/10. 5/10 would be half, so 6/10 is going to be more than half. All All right, so now I can take a look at these, imagining my number line here. Something close to 0 is going to be smallest. So 1/8 is going to be smaller than 1/2 would be next. So 3/6, I'm using my original fractions here. And 3/6 is going to be less than the one that is more than half, which is 6/10. Okay, so I put all three of those fractions in order from least to greatest without having to do any common denominators. All right, I'll take a look at this one. Asking myself those same questions. Okay, 5/10, which benchmark is that closest to? It's equal to 1/2. 2/3, got an odd number here. Half of 3 is 1.5, so this is slightly greater. So this is more than half. And 7/12, 6 is the half of 12, so this is also more than half. Okay, so I am going to have to find a common denominator, but I don't have to find a common denominator for all three of these numbers. When I was in school, that's how they told us to do. You find a common denominator for everything, but it's not really necessary when I already know this one's going to be the least. And then I only have to find a common denominator of 2 numbers instead of 3. So I'm going to make 5/10 the least, and then both of these I'm going to have to find a common denominator for. So what can thirds become? And 12ths? Well, both of those can be made into 12ths. This already is 12, so that makes that easy. So 3 becomes 12 by a factor of 4. 2 times 4 is 8. So if this one is 8/12 and this one's 7/12, 7/12 is going to be the next smaller. So 7/12, and then the largest, I'm going to do my original fraction, 2/3. So 5/10 is less than 7/12, which is less than 2/3. If I want a common denominator for all three of these numbers, I'm looking at doing 60ths. So that's just a lot more work and stuff I wouldn't have to do if I can just look at this and know right away that 5/10 is a half. All right, thank you so much for watching. That was a really important skill. We're going to practice a lot on over the next week and a half. Thank you for taking so much time to watch. Please go ahead and like my video. All right, thank you.